Right, now we're coming to some people's favorite section, the nature of roots of a quadratic equation. So nature of roots, many people are like, what the hell is nature of roots? Now, if you have to think of it English way, right, nature and roots go together, don't you think so? But it's not about that. It's about how do you describe something, the nature of it. His nature is calm. That means that's just how it is. What is its natural way of being? What is its makeup? How would you describe it? What is its description about something? And roots is basically the x-intercepts. So your roots are your x-intercepts, and nature meaning describe it. Right? How is it? What can you say about it? Right? So the roots of an equation refer to the solutions of that equation. So x-intercepts or solutions, you can also call them. When solving a quadratic equation, one is also finding the x-intercepts of a quadratic function that are represented. Now, how do you describe roots? Right, roots can be described in three different ways. So it always will have three keywords, okay? Three keywords. It can be, number one, real or non-real. It can be real or non-real. Number two, it can be rational or irrational. Or number three, it can be equal or it can be unequal. Now, some of you will be like, what the hell did I just say? So, any quadratic equation must have these three words here. So you can either have this. It can be a combination of words as long as it's from each of the category. 1, 2, 3. So, for category number 1, right? So for category number 1, to know if something is real or non-real, right? Real or non-real. Real basically means it exists in the world. Non-real means it can't exist in the world. It doesn't come here, right? Rational means that it can become a fraction, your answer. Irrational means it can't become a fraction. It's like a decimal that continues on for infinity, or you can't quantify the number. Equal means there's only one x-intercept. Unequal means there's two x-intercepts. Here also means there's two x-intercepts, but both of them are the same. So it's the same intercept. Here it's different intercepts. Now, how would you go about working this out? How would you go about working this out? So, through the quadratic formula, right? So remember when we have the quadratic formula, we say here x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a, right? And sometimes when you type it in your calculator, you get error, maths error. And sometimes when you type in your calculator, you get an answer, but it's a different kind of answer. Sometimes you get whole numbers, sometimes you get decimals, sometimes you get fractions, sometimes you get things that say round up to 2 decimal spaces. Now, this whole nature of roots has to deal with this quadratic solution, because we found that when you have something inside here, if it's a negative number, it doesn't exist. It becomes non-real. That's where the math error comes. If it's a certain way, it will be something. So this thing here that's underneath here, we call it delta. We call it delta. So this means delta. Okay, so delta is equal to b squared minus 4ac. What does the a represent? What does the b represent? What does the c represent? Those represent your a, b, and c from your quadratic. So if I have y equal to ax squared plus bx plus c, that is your a, your b, your c. Okay, so when you want to know if something is real, right, if you want to know if something is real or not real. This is how you're going to go about doing it, right? So I'm going to give you like the cheat page now, so you got to pay attention now. Right, you ready? So for number 1, if it's real or non-real, right? If it's real, theta will be greater than 0. If it's non-real, theta will be less than 0. So that means your answer here would be greater than 0. It's a positive number, therefore it will be real. If your answer here was a negative answer, it would be non-real. Then number 2. So I'm going to use purple now because some people like color. Right, let's go to number 2. To know if it's rational or irrational. Right, if something, now in your delta, so rational, so I'm going to say Q, or irrational. You know, Q with the what you call that thing, inverted comma. One of, yeah, I think that's what it's called. Right, with the quote mark is basically this, right? So to determine if this is rational, theta must be a perfect square. What are perfect squares? Perfect squares are basically like 1, 4, 9. You know, something times itself will give you that. So if you can find the square root of that number, then it's a perfect square. And if the square root is a whole number, it's a perfect square. Right? Irrational is when it's not a perfect square. Right? So when it's not a perfect square. So that can be any number that's not a perfect square. So like 8, 3, etc. Then if you want to work out the last one is number 3. Right, so number 3 is when is it equal or unequal? It's equal or unequal. Equal means both my x values are the same, so that means my graph will be sitting at 1 point only there. And unequal means my graph cuts at 2 spaces that are different. Okay, so what does equal mean? Equal will be when x is equal to 0. Okay, if x is equal to 0, it will be equal. But if x is greater than 0 only, then it will be unequal. So what you need to know is you need to know this part here. Right, you need to know this part here. You need to know it off by heart, because every single quadratic equation is going to be called according to 1, 2, and 3. It's going to be called according to, is it real or non-real? Is it rational? Is it irrational? Is it equal? Is it unequal? Okay, now memorize this quickly, pause it, memorize it, and now we're going to do some sums, and you need to do it first. So I'm going to give you 3 things, examples, and you need to do it, and let's see how you're going to get the answers. Right, right, so example number 1 is going to be this. Right, number 1, x squared plus 3x plus 4 equal to 0. Right, number 2. So start doing it now. X squared minus 5x minus 6 is equal to 0. And number 3, 2x squared plus 3x minus 7 is equal to 0. Oh, let's give you another one because we like you so much. Number 4, x squared minus 6x plus 9 is 0. Right, you got these 4, pause it and do it yourself right now. Right, so let's see now. So what we're going to do first, we're first going to find delta. So we're going to find delta is equal to b squared minus 4ac. Then we're going to substitute the values of b, a, and c. So b here is 3 squared, right, minus 4a is 1, c is 4. So my delta is equal to 9 minus 16 which is delta is equal to minus 16. So therefore, what is it? It's a negative 7. Oh, yo, yo. So then you say, therefore, the roots are non-real. Why? Because delta is less than 0. That's why. Because delta is less than 0, it's non-real. Then we go to number 2. Right. Now number 2's one. If you go to number 2, it was x squared minus 5x plus 6 is equal to 0. So again, you only can do delta if all the numbers are on the left hand side and the right hand side is equal to 0. So that's how you can get the A, the B, and the C. So what's my B? Minus 5 squared minus 4, 1 times 6. Right, then I'm going to say 25 minus 4 times 6 is 24. So I'm going to get underneath there. Right, so minus 5 minus 4 minus 24, I'm going to get 1. Ooh. Right, let's see that. So what is delta equal to? 1. So now let's see. Right, so we're going to say, now number 1, is delta greater than 0? Now we're doing, is it real or is it non-real? So is delta greater than 0? It's greater than 0, therefore it's real. Number 2, is it rational or is it irrational? Now rational means it has to be a perfect square. Irrational is not a perfect square. Is this a perfect square? Yes, it is. So therefore it is rational. And finally, 7 is equal to 0. What I'm going to do here, I'm going to say delta is equal to b squared minus 4ac. And say delta is equal to 3, right, squared minus 4 times 2 times minus 7. And I'm going to get my answer to be 9. Right, what's 9? Positive 8 times 7. Oh, okay, so my final answer is going to be 65. Right, so 54 plus 9 is 65. So now, number 1, is it greater than 0? Yes. So therefore it's real. Is it a perfect square? No. So it's irrational. Is it equal to 0? No. So it's unequal roots. Right. Now let's go to a very special one. I want to do a very special one with you. The last one is a very special one with you. Right, so I need to show you a very special one. Right, so we're going to say x squared minus 6x plus 9 is equal to 0. So delta is equal to b squared minus 4ac. So what's b? Minus 6 squared. 4a is 1, c is 9. So if I type this in my calculator, I'm going to get 36 minus 36, which is 0. So delta is equal to 0. So let's start with the first one. Is it greater than and equal to 0? Because that will make it real. That's what we forgot to tell you in the beginning. It has to be greater than and equal to 0. Right, so it has to be greater than, so let's change it here. It's supposed to be greater than and equal to 0. So if it's greater than and equal to 0, then it will be real. So let's put it here. Right, if it's greater than and equal to it, then it will be real. Because if it's equal to it, it will still be real. Right, so what we're going to go here, you're going to say it's equal to 0. So is it real? Yes, it is real. Is it rational or is it irrational? Now someone will be like, no, what the hell, it doesn't make sense. What does make something rational? Something that makes something rational if it's a perfect square. Or if you type it like square root of 9, I get 3. So it becomes a whole number. So now type in square root of 0 and tell me what you get. I get 0. And isn't 0 a whole number? So therefore it is rational. And because it's equal to 0, it's going to be equal roots. That's all you need to know now. Okay, so let's recap again. Let's redraw our three different things. Right, number one, if it's real or non-real. So delta has to be greater than and equal to 0, or if it's non-real, delta must be less than 0. And the next one is it rational or is it irrational? Right, so is it rational or is it rational or is it irrational? So how is it? Is it rational, irrational? If it's rational, it's a perfect square. So delta is equal to perfect square. So delta is not equal to a perfect square, then it'll be irrational. And finally, is it equal or is it unequal? If it's equal, then delta has to be equal to 0. If it's unequal, then delta must just be greater than 0. Right? And that's what you need to know for the basics of the nature of roots. That's what many people will have. Okay, but sometimes people get confused and be like, oh, I don't know how to do this, etc., etc. It's so confusing. But let's discuss this. Okay, now when you have things like this, sometimes it can be really, really, really crazy. You're gonna get like crazy ones. You're gonna get difficult nature of roots. Right, so I'm gonna do two things with you. Right. I'm so excited and I just can't hide it. This one here says show that x open brackets 6x minus 7m is equal to 5m squared are real, rational, and unequal. And it says m is not equal to 0. Right? So say they want us to show it. Now some of you will be like, oh my god, I don't know how the hell to do this. Step number one is always multiply out the brackets and move everything to the left hand side. So I'm going to say x 6x minus 7m is equal to 5m squared. 6x squared minus 7xm, and then move it that side there, it's going to become minus 5m squared is equal to 0. Right, now if I had to rearrange this properly, this is my x squared, so x squared is here. If I had to move this, I say 7mx, because I'm just rearranging it, and minus 5m squared, right, equal to 0. Now, you know that a basic quadratic equation is ax squared plus bx plus c. So, can you see the coefficient in front of the x squared? So, everything in front of the x squared here, that's my a value. Everything in front of the x is my coefficient for b. So, what's in front of the x here? Minus 7. And finally, whatever is left over is my c value. So whatever left over here. So c is this whole thing here, minus 5m squared. Right. Now we have our a, we have our b, we have a c. Now we can do delta. Don't be scared. B squared minus 4ac. So what's my b? Minus 7 squared minus 4. What's my a? Oh, what the hell? What did I forget to put here? 7m. You see? You see? Stupid mistakes like this will get you nowhere, people. Will get you nowhere. So minus 7m. Let me just rewrite this again. Right. Then you have minus 4, and then you have 6, and then you have c minus 5m squared. Right. So what I'm going to do here, a negative and a negative gives me positive. So 7 times 7 is 49m squared. Here I'm going to get positive 4 times 6 times 5, I'm going to get 120m squared. If I add them together, I'm going to get 169m squared. 169m squared. So, let's see. Now they said prove that it's real. So, if you have a square, if m was a negative number, it would always be a positive in n. So you're going to say here, right, n is squared, therefore 169m squared is greater than 0. It's always greater than 0. So therefore it is real roots. Right, so that's the first one we did. The second part says prove that it's rational. So you say the square root of 169, so the square root of 169 is 13, and the square root of m squared is m. So therefore it is q, which is